The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, thanks for joining us today. We're just allowing a few people trickle in, so we'll get started in a second here. Just while you guys are waiting, I wanted to remind you to make sure to use the question and answer feature. You can submit a question and we'll make sure to get to it in the end. If you've pre-submitted a question previously when you registered, if we don't answer it throughout the course of the webinar, we'll also take a look at it at the end and hopefully get you an answer from our specialists here. It does look like we have a good number of people in here already, so since we're a little behind, we'll get started. Hi. If you're here, you're worried about digital twins. In the world of new construction shipbuilding, the value that digital twins can bring to a program and the steps to achieve that value are more and more understood each year. But for sustainment and in-service support, most have an idea of what the ideal is, but getting there in reality is proving tricky. So what's the role of the digital twin for sustainment? And how do we make that first step to taking advantage of the digital twin? What needs to be different when we're talking about new builds versus existing vessels? These are just some of the questions that Simon and Malay are going to tackle today. And like I said, if you have any questions of your own, please make sure to use the Q&A feature and have us answer them after the session. So who are we? Just as an bit of a brief introduction, my name is Greg. I'm responsible for showcasing innovations in shipbuilding and the successes that our customers are having with those innovations. Simon is an SSI solution specialist with almost 20 years of naval architecture and marine engineering experience, and he's got a proven track record in the management and development of professional, multidisciplinary design packages across the shipbuilding space. And Malay Paul is an SSI solution specialist with significant experience in PLM with enterprise systems for shipbuilding. He has over 25 years of experience with both naval and commercial programs, all in the areas of design, construction, data management, and more. So the topics for today. What is a digital twin? Let's make sure we're all on the same page. Digital twin is one of those buzzwords that means something to everyone. So we want to make sure we're all speaking the same language when we're talking about the digital twin. We're going to talk about the differences between a digital twin for existing vessels and new builds. What needs to be different, what stays the same. Simon will be touching on that. We're going to be talking about capturing operations data. If the ship's in service, what do you need to actually capture and bring to your digital twin? And then, number 4 there, we're going to be talking about bringing all that information together to make it useful, to make it accessible, and to make it actually valuable to your business and your organization. And like I said, we're going to have time at the end for questions and just a brief overview of what we covered today. So without further ado, I'll hand it over to Simon, who'll take you on our start of our digital twin journey here.
Thanks, Greg. I'm not sure if it's just me. I'm still seeing the team introductions on the screen. Same for you, Malay?
Should be on the, what is it, digital twin?
No, I see the next slide. What is a digital twin?
Okay, all good. I'll carry on. So let's explore what a digital twin is and what a digital twin is not. Quite often the term is thrown around very loosely, with any form of digital artifact sometimes being considered a digital twin. If you look up a digital twin, you'll see it's commonly referred to as a digital asset for a physical product. We believe this is only true if the information captured is sufficient to serve the purpose for which the digital twin exists. Generally, to satisfy the purpose for which it exists, multiple related configurations need to come together. A surface model of the ship can be used for naval architecture analysis, generating marketing content, or showing up top to create a little 3D print of a miniature model. This alone is not fit to support sustainment activities. Similarly, the point cloud scan shown below provides a 3D representation of the space. Designers can visualize what is there, take measurements. However, without the supporting information such as part data, it alone is not fit to support sustainment activities. So now we'll take a look at some of the pieces of the puzzle that make up a digital twin. To have sufficient information to serve the purpose for which the digital twin exists, it's typically a combination of the following: models, bill of material data, drawings, and reality capture. In many cases, as built or as is model data may not be available or may be incomplete. Reality capture, like laser scanning, supports this information with an overlay of the ship's configuration. Designers can use this information to identify what information has not been captured in the model and what information differs, such as equipment being installed in a different location other than specified on the drawings. And we all know quite often that's the case. We find that shipbuilders often have more information than they think available. This includes CAD models from different vendors created using different software, various spreadsheets, databases, scans, catalogs, and requirements. To overcome shipbuilders' challenges, we believe a single source of truth for information is necessary. This platform must be vendor neutral, tightly integrated with engineering, and help effectively track and manage constant changes being made. Capturing all this information in a single platform probably seems far-fetched, but it becomes more manageable as we look at the different levels of information required for sustainment compared to building construction. Different information is required for different phases of design. During the build phase, fabrication details, assemblies, cut lists, nests, and spools are all very important. This information together could be called the design and build digital twin. When capturing the as-is configuration of the ship for through-life support, arrangements, class drawings, systems and branches, the work breakdown structure, ship work breakdown structure, SWBS as it's commonly called, particularly in North America, and as-is models are important. I flagged a couple of items on this list. It's important to capture the ship work breakdown structure where possible, as it provides a great way to search the digital twin for information. For example, filtering for a system like a build system, propulsion system, any relevant data that you need to find. And when I mention as-is models, that may include 3D models, reality capture, or a combination of both. I've mentioned reality capture a couple of times, and point clouds. So it's time to look at what those are. Point clouds and photogrammetry are usually created using a scanning device mounted on a tripod that scans the compartment, spins around capturing photos and points. The tripods move throughout the vessels and the information stitched together to create a digital representation of a ship. The point clouds are millions of points, millimeters apart, defining the space. It's not uncommon that a compartment in a ship would be made up of 100 million points. On the left, we see an example of this. This technology has been rapidly evolving over the past few years. The first time I personally used it about 10 years ago, the scans all presented in monochrome, and you kind of had to zoom around to actually work out what you're looking at. And now they almost look like photos from a distance. On the right is an example of photogrammetry, measurable photos. Often these technologies are combined, and in this case, they're captured from the same scanning device. There's often a misconception we see that the technology creates a complete digital twin. However, scans only capture what they can see, leaving unknowns behind equipment, behind linings, behind insulations. And there's also no properties associated with it, except if you're lucky enough that every system on your ship's well labeled and visible from where the tripod is. This technology is best used with other elements that make up the digital twin to validate the design, identify missing information, and to identify clashes when designing a refit solution. As shown here, the point clouds are overlaid within the product model in the CAD system, and modelling has begun on a pipe system flag for an upgrade, shown in green. Within the CAD system, often pipe center lines can be identified and automatically generated in the scan to help rapidly model anything required. When we create a digital twin for a vessel, it's important to first determine the information that is sufficient to serve its purpose as a digital twin. A ship may be 20 years old and under its 5th owner. Shipyards need to gather all the usable, relevant information, which may be comprised of data from multiple sources. Bringing this information together in a vendor-neutral platform, overlaid with reality capture to validate the data against the as-is configuration of the ship. But what about for new builds? In the case of new builds, many contracts specify that a digital twin is to be delivered with the ship to support ongoing sustainment activities. Shipyards have an opportunity to add attributes to the model to support sustainment activities such as part supplier reference numbers, SWIBIS or shipwork breakdown structure codes, allowing seamless transition from build to in-service support. It can also be determined if design and build history needs to be included or only the as is model captured as a starting point. Capturing this information throughout the whole design process from the initial ship requirements onwards is often referred to as the digital thread. Click on a pipe, see the spools, see the revision history, see the requirement that's specified to have that system in the first place. I'll now hand it over to Malay to chat about capturing the information in a PLM system, including the operations data. Thanks, Malay.
Yeah, thanks, Simon. Once a vessel is delivered to her client, the operation phase begins, which can easily last 30 years or more. A huge amount of data is collected over the operation life of a vessel, which is used for sustainment activities and also for improving designs of next in series vessels, as well as of systems and equipment by OEM suppliers or OEM manufacturers. The operations data collected include service records of replaced items under warranty and maintenance, changes made during repair and refit, periodic class surveys, etc., as well as real-time or near real-time ship data collected through onboard sensors and from other sources as ship sails. These data include routing information like GPS coordinates, heading and speed, then machinery information like engine load and vibrations, environmental data like met ocean measurements, to name a few. All these data or information become part of the digital twin and is used for various purposes like monitoring, prediction, and decision making. To take an example, machinery data collected is used for monitoring fuel consumption, for prediction, and to plan for maintenance. It is important to note that the real-time data which is collected from a vessel through various sensors have to go through steps of data aggregation, data analysis, and reduction before they become part of the digital twin. Moving on, while we build the digital twin, where does the digital twin reside? The repository of the digital twin is a product lifecycle management system or a PLM system, which on the screen is on the top left is mentioned PLM system. As Simon mentioned earlier, the digital twin in some form or the other is often built these days as part of the design build phase, which if made available to the ship owner or operator can be a very good starting point for building the digital twin for the sustainment phase. For existing ships with no digital twin available from design build phase, there is no alternative but to start with preparing a fit for purpose as-built model of the vessel, which can be used for building the digital twin for sustainment. Either way, it is a PLM system which brings all this information together in the digital twin. The PLM system is the information repository and allows access and use of the information or data as needed. If a PLM system has been used during the design build phase of a vessel and the same used subsequently to build the digital twin for sustainment, then the PLM system provides the digital thread between the different phases of a vessel's life cycle, indeed right up to its decommissioning and disposal. Now let's taking a close look at the schema on the screen. The items under asset and analysis would come from the design and engineering and build phases of a vessel or from an as-built model. Below analysis, we find measured data, which would include time series data from sensors, which are covered in the previous slide. Below measured data, we find schema, where we organize the data and information logically as per ship systems, as that is the way data would normally be necessary for carrying out sustainment activities. There are different schemas in use, like SWBS or ESWBS. We find an example of ESWBS on the right, bottom right, and SFI, which Simon mentioned earlier. The role of the PLM system is vital, as it is not only a repository of the digital twin, but also provides a host of capabilities like maintaining different versions of the vessel, like as built, as maintained, etc. Maintains the vessel and information hierarchy as per SWBS, for example, or SWBS, for example. Provides various views of the vessel, like functional, for example, propulsion system view. Maintains variants in case of a class of ships, and provides workflows and change management to carry out the actual sustainment activities. Did I hand it over back to you?
Yes, thanks, Malay. Thanks, Simon, as well. So we heard a lot of information there, and we all have to realize that this is just the beginning, right? The first step to our digital twin is to bring it together. So today, what have we seen? We've seen that you do need different information for existing vessels compared to new builds when you're talking about sustainment activities. You need to capture operations data right from on board the vessel and bring it into your digital twin. And so where does that digital twin live? Well, in our opinion, digital twin lives inside of a PLM system. So that's the first step. So where do we move on to from there? Well, we can talk about managing the vessel over the life cycle, managing a class of ship, managing a single ship, connecting those platforms and making sure that all the organizations involved in maintaining a vessel all are working from the same digital twin. And we can talk about managing major repairs and refits. So getting engineering data from the digital twin, actually making the repair, making the refit, and then capturing that information back into the digital twins so it's ready for future use and it's accessible for forevermore. So those two topics we're going to save for a later session. We want to get in depth on them. We want to actually provide a lot of value to you guys and make sure that we're not just skimming the surface. We're able to give you something to take away and bring to your organizations. So make sure to stay tuned for that, and we'll provide registration information for those sessions once they're available. And to finish off today, we did have a few questions come in during the presentation, and we had a few before, so we're going to go ahead and answer them. So I invite Simon and Malay to kind of come back to the stage, so to speak, and we'll touch upon some of the questions we had. So the first one, how detailed should my digital twin be for my company? And then how do you implement the information from the digital twin into our existing processes? So this is a great question. I think it's something that's top of mind for for a lot of organizations is, well, okay, we have a digital twin. We just talked about what it's made up of. How much detail do I actually need? So I'm not sure if Simon, maybe you want to answer this one.
Yeah, I'll jump on that one. Thanks, Greg. So if we take the example of a pipe system, it's the valves, the pumps, the equipment that's important, but the pipe runs themselves consisting of straight pipe, elbows, all that stuff, that's not important because it doesn't change the design. It's important when you're building the ship, but it doesn't change how the system operates functionally. So likewise with the structural foundation, all the plate parts and things that make up that structural foundation, you'll never need to rebuild that structural foundation, but you need to know it's there on the ship, and you may need to reuse it if you're changing the equipment attached to it. So what's important is you, for the example of pipe, you at least have the whole system captured, and then ideally any valves or parts like that and the foundation captured as one single entity is perfectly acceptable to support most refit activities. How you can implement the information from part two of that question, sorry, was how to implement the information from the digital twin into your existing processes. And as Greg touched on, capturing the digital twin creates a single source of truth for manufacturing information or operations information. So that becomes your starting point for any sustainment activities moving forward.
Thanks, Simon. We did have another question here. So, in your opinion, who is the targeted user for the digital twin? Is it SMEs, small and medium-sized enterprises? Is it big industry players that deal with more complex projects? If it is small and medium-sized enterprises, what kind of value can those enterprises get? So I think let's just start with the first part of that is who's the digital twin for when you're talking about scale of a shipyard or scale of an organization, maybe more generally.
I would say that it's for anyone needing to use that information to support the vessel. There's a lot of SMEs use that information. One example is to retrofit ballast water treatment systems to vessels to meet compliance. So quite often that work is undertaken by an SME, or for naval vessels, it's quite often a larger company managing those vessels throughout their lifetime. So really it's important to all stakeholders.
Would there be different degrees of a digital twin you could implement in that sense? So a smaller company could start with less?
Yeah, absolutely. A change might only affect a couple of compartments, and capturing the information in those relevant compartments is enough information for them to carry out the work they need to do. So it doesn't always necessarily have to be the full vessel, a digital twin of the full vessel.
Right. All right, so that might be all the questions we have for today. Just going to check here. Yes. All right. Thanks everyone for joining me today. For joining me, Simon and Malay today, rather. Thanks, Simon and Malay, for your expertise. Make sure to stay tuned to SSI on our website. You can read posts on our Shipbuilding Solutions blog from both Malay and Simon. They're bringing their insights there once a month, maybe even a bit more often than that if you're lucky. And you can catch our other blogs, the Lighthouse blog and the Waveform blog, where our co-CEO Dennis kind of shares his insights on the shipbuilding industry. Stay tuned for the next episodes of the series. We're going to be talking more about the digital twin and how it can bring value to your organization. Thanks so much for joining us.
Thank you.
Yeah, thanks everyone.